Pulsars are what's left over after a massive star, much bigger than our Sun, collapses at the end of its lifetime. So a massive star, maybe 10 times the size of the Sun, or maybe even more, maybe even 20 or 30, will explode as a supernova, and the center of the star collapses to become a neutron star. As all the other material around it moves away at very, very high rates of speed for the supernova, the star itself, the neutron star, is spinning very, very rapidly. There's a magnetic field that was in the original star, 1 trillion times stronger than that on the Earth. That gets compressed and gets frozen into that surface of the neutron star, so now you have a strong spinning magnet basically in space, and that causes all sorts of radiation to be generated. What normally happens on most pulsars is you get radio waves that come out of the magnetic poles of the neutron star, and because these things are spinning, and because the magnetic poles don't happen to be aligned with the rotation axis, just like on Earth, if that beam of radio waves passes through our line of sight, we see pulses of radiation, and that's why we call them pulsars. A normal pulsar that comes from a supernova will tend to last somewhere between 10 and 100 million years. Well, if you think about it, our universe is more than 10 billion years old, so if something lasts 10 to 100 million years, that's just a very short amount of time. When a star explodes, that pulsar spins for 10 or 100 million years and then is rotating too slow to cause that radiation to escape anymore, and basically it's just a long dead neutron star. But what happens is if that neutron star has a companion star, a star like our Sun for instance, eventually that star will turn into a red giant. And as it does, as it continues to orbit the neutron star, it transfers material in the form of a disk onto the neutron star. And that transfer of material also transfers angular momentum, which means that you spin that star, the neutron star, faster and faster. So you end up getting a neutron star that spins very rapidly, up to the fastest one that we know, which we actually found with the Green Bank telescope, is spinning 716 times per second. That's faster than a kitchen blender spins. And then these things can last forever, because once you spin them that fast with a much smaller magnetic field, they'll last for billions of years rather than just tens of millions of years.